Hello, this is not your chem tutor, and in this video, I will teach you Avogadro's law under the topic of ideal gas laws. As usual, I included examples at the end of the video so we can practice some calculations. First, let's discuss the statement of Avogadro's law. It says that at constant temperature and pressure, the volume of the gas is directly proportional to the number of moles of the gas. Again, you can only use Avogadro's law if the condition says the temperature and pressure are constant. And the relationship is the volume of the gas is directly proportional to the number of moles of the gas. So what does directly proportional means? This means that if you increase the number of moles, the symbol for moles is N. So if you increase N, volume will also increase. On the other hand, if you decrease the number of moles, the volume will also decrease. So that's what you mean by directly proportional. And you can see it in the graph of Avogadro's law. It's shown in the screen. You can see that as the number of moles increases, the volume also increases. Okay? Now let's proceed to the formula for Avogadro's law. The formula is very simple. It's V1 over N1 equal to V2 over N2. Now let's define the variables. V1 is your initial volume and V2 is your final volume. Now, students usually ask, is there a specific unit of volume that we should use in Avogadro's law? The answer is no. There is no specific unit. You can use any unit of volume as long as you are consistent in using that unit. So for example, if you use ml for V1, then use ml for V2. If you use liters for V1, make sure you use liters for V2. So usually what I do is that I use the unit given in the problem and I stick to that unit. Okay? Now, N1 is your initial number of moles and N2 is your final number of moles. Since N1 and N2 are number of moles, the only unit you can use for N1 and N2 is of course moles. Okay? Now let's try to answer some examples. For example 1, a balloon containing 1.78 moles of helium has a volume of 4.80 liters at a specific temperature and pressure. What will be the volume if the amount of gas is increased to 2.50 moles under the same conditions? Okay, so we will use Avogadro's law, but first let's determine the numbers that we are going to plug into the equation. So 1.78 moles is our initial number of moles, so this is our N1. 4.80 liters is the initial volume, and 2.50 moles is our final moles, or N2. So what is missing in this problem is V2, because the question is asking for what will be the volume. So we are looking for V2. Now let's substitute the numbers. We have 4.80 liters divided by 1.78 moles This is equal to V2, just write V2 because it's unknown, divided by 2.50 moles. You can do cross multiplication. So this becomes 4.80 liters times 2.50 moles equal to V2 times 1.78 moles. If you want to solve for V2, divide both sides of the equation by 1.78 moles. So 1.78 moles cancels on the right side. So what remains on the right side is V2. And on the left side, moles will cancel, and what is left is liters. So, and if you solve this in your calculator, 4.80 times 2.50 divided by 1.78, the answer is 6.74, and the unit is liters. So this is the answer to the question. Let's proceed to example 2. If the number of moles is increased to thrice its initial amount, what happens to the volume of the gas? Assume constant temperature and pressure. So the first part of the problem says that the number of moles is increased to thrice its initial amount. So what does this mean? This means that the final number of moles, or N2, is thrice the initial number of moles. Or you can write this as N2 is equal to thrice of N1. Now, we can use the Avogadro'S law. So we have V1, so just write V1 over N1 is equal to V2 over N2. But we know that N2 is equal to 3N1. So put 3N1. And then you can do cross multiplication. So this becomes V1 times 3N1 equal to V2 times N1. If you divide both sides by N1, N1 cancels on the left side and on the right side. What is left on the right side is V2, and what is left on the left side is V1 times 3 is 3V1. So this is the answer to the question. Or in words, you can write the volume also increases to thrice of the original volume. Or you can write the equation V2 is equal to 3 of V1, 3 times V1. And this is the answer to the question. So for our last example, a 2.10 liter sample of nitrogen gas in a flexible container contains 0.650 moles of the gas at a certain temperature and pressure. Assuming constant temperature and pressure, how many more moles should be added to increase the volume to 5.50 liters? So we will use again Avogadro's law. Let's determine the variables. So 2.10 liters is our V1, 0.60 moles is our N1, 5.50 liters is our V2. So what is missing in this problem is N2. So let's use Avogadro's law formula. 2.10 liters over 0.650 moles this is equal to 5.50 liters divided by N2. So just write N2 because it is unknown. So you do cross multiplication. So you have 2.10 liters times N2 equal to 5.50 liters times 0.650 moles. To solve for N2, divide both sides of the equation by 2.10 liters. So 2.10 liters cancels on the left side. So what is left on the left side is N2. And on the right side, liters will cancel. And what is left is moles. And then you solve using your calculator. 5.50 times 0.650 divided by 2.10, and the answer is approximately equal to 1.702 moles. So our final moles is 1.702 moles. But this is not yet the final answer. If you read the problem carefully, it says here how many more moles should be added to increase the volume to 5.50 liters. So we know that our N1 is 0.650 moles. The question says, how much more should you add to get to 1.702 moles? So basically what you need to do is just subtract 1.702 moles minus 0.650 moles, and the answer is equal to 1.052 moles. So this is the final answer to this question.